Right, let's solve the following simultaneous equations using matrices and interpret the solution geometrically. Again, in order to use matrix methods, we're going to need to have to set up our matrices and then show our matrix algebra. So we have 3x minus 2y equals 6 is equation 1. Negative 6x plus 4y is negative 12 is equation 2. And we're going to let x be our variables that we don't know. Our matrix A will be our coefficients in front of our variables, and our matrix B will be the solutions. And then we're going to show our matrix algebra. So AX equals B. Inverse AX is inverse AB. IX inverse AB and X inverse AB. Now remember, in order to find our inverse, we need to find our determinant. And our determinant is going to tell us how many solutions we've got. So our determinant of A is going to be AD minus BC. And that's going to be 12 minus 12, which is 0. So that tells us that our matrix is singular and there are either infinitely many solutions or no solutions. So matrix is singular, therefore infinitely many solutions or no solutions. All right, so now we're going to check using our gradient intercept form what these lines look like. Okay, so in the form y equals mx plus c, which is our gradient intercept, we have 3x minus 2y is equal to 6. Negative 2y is negative 3x plus 6. And y will be 3 on 2 is 3. And in the other one, we have negative 6x plus 4y is negative 12. 4y will be 6x minus 12. Y will be 6 on 4x minus 3, and 6 on 4x can simplify to 3 on 2x minus 3. Now notice my gradients are the same and my y-intercepts are the same. So these are the same line essentially. They are two lines which coincide with each other. Okay, so therefore the two lines coincide and there are infinitely many solutions. All right, let's sketch it, and then we need to talk about what we need to do when there are infinitely many solutions. So I have a y-intercept at negative 3, and my gradient is 3 on 2. So 1, 2, 3, 1, 2. There's my other point. And there are my two lines. 3x minus 2y equals 6, and negative 6x plus 4y equals negative 12. Okay, Now, when I have got an infinite number of solutions, I can't, well, no, I've got two equations which are giving me an infinite number of solutions. And what we do in that case is we actually define another variable called the parametric variable or the parameter, so that for any x coordinate or any y coordinate on both of those equations, I can find that value. And we call this a parametric equation. And we can define either x or y as our parameter. Doesn't matter which one you define. Basically, you just need to choose the one that's going to be easiest. I'm going to do both of them. Either of these would be correct in an exam situation. Okay. So on this side, I'm going to let y be my parameter, and on the other side, we'll let x be the parameter. So we take one of our solutions, so 3x minus 2y equals 6, and I'm going to rearrange that so that I get x in terms of y. So 6 plus 2y over 3. That's to find any x coordinate. And then we get y equal t. So this is my parameter now. Okay. So therefore, if y equals t, we're now going to make x in terms of t. So 6 plus 2t over 3. And then to find any coordinate on the line, so therefore, to find any coordinate on the line, I'm going to have my x value, which is going to be 6 plus 2t, which I can actually simplify further. And my y value will be t, where t is a real number. Okay, and that's my infinite number of solutions. So therefore, there are an infinite number of solutions of the form, and I am going to simplify that fraction. So 2 plus 2 on 3t, and t where t is an element of the real numbers. We could also have said, well, 3x minus 2y equals 6, and I could have put it into my y equals, or my gradient intercept form, which I have done already. So negative 3x plus 6 over negative 2, and we have already, maybe that's a good reason to have chosen x, 3 over 2x as my parameter, because I've already got that equation and that. So now I'm going to let x equal t, doesn't matter which one you call it. So therefore y will be 3 on 2t minus 3, and therefore there are an infinite number of solutions of the form, and now what we've got is t and 3 on 2 t minus 3 for my coordinates, and t is a real number.